Okay, this is example 3 from the Trig 1 notes. It says find the values of the 6 trig ratios for alpha and beta. Those are just Greek letters for A and B. And we'd like to use them for angles, but we don't have to. We could use A and B, but we just chose alpha and beta. So don't freak out about those. And so there was an acronym that we learned for the trig ratios. There was SO, Ka, and TOA. Okay? The sine, so if we look at it right here, the sine is the opposite over the hypotenuse. So we take the sine of alpha is the opposite side. The opposite for alpha is 3. And then the adjacent, over the hypotenuse, excuse me. This is hypotenuse. So the hypotenuse in this triangle is, well, I don't really know it. Or do I? Well, what kind of triangle is this? It's a right triangle. Okay? And since it's a right triangle, we know that it's a 3 squared plus 4 squared equals, well, if you know your Pythagorean triples, 5 squared. So instead of putting a question mark on the bottom here, we can put 5. The hypotenuse is, instead of writing a question mark, we can write 5 here, because it's a 3, 4, 5 right triangle triple. I'll write a better 5 here. Okay, so that's the sine of alpha. What is cosine? Okay, cosine, let's see here. The cosine of alpha is the adjacent side to the angle. Well, the adjacent is right here, is 4. There's the adjacent. And the hypotenuse, well, we just figured it out, is 5. And then we have the tangent. The tangent of alpha is the opposite side, right here, to alpha, which is 3, and the adjacent side, which we already have right up there, which is 4. There's 3 of the ratios for alpha. I'm going to erase this, and I'll do the beta ones. It's the same SOHCAHTOA, so let me do that here. Okay. But we're going to deal with beta now. So we're dealing with beta here. Okay? And for beta, this is the opposite, and this is the adjacent, and this is still the hypotenuse, and it's still equal to 5. So for beta, we're going to do the same thing. So sine beta equals the opposite, 4, over the hypotenuse. Okay? And the cosine of beta is going to be the adjacent, right here, this is the adjacent, 3 over the hypotenuse, which we already got here, which is 5. Okay, and then the tangent of beta, well, it's going to be 4 over 3. It's the opposite. It's the opposite over the adjacent. The opposite over the adjacent. And there you go. And what you'll notice is if you compare it to the sine of alpha, you got 3 over 5. And if you compare it to the cosine of alpha, like we had on the other page, you've got 4 over 5. And then if you compare the tangent of alpha, you get 3 over 4. So there is so it looks like cosine beta is the same as the sine of alpha. You notice they're just opposite triangles, opposite angles, so they use the opposite of it. If we do the sine of beta, looks like the same as the cosine of alpha. And the final one, the tangent of beta is the reciprocal of the tangent of alpha. They're just flipped versions of each other. So there's those patterns in there if you're using if you're in the same triangle. Thank you.